This is the second homework on this section, solving systems by graphing. And just like the previous homework assignment, this first part also does not ask you to solve. They don't even ask you to graph. They graph it for you. They graph all the equations for you. All you have to do is determine if it's consistent or inconsistent. And if it is consistent, you have to determine if it's consistent independent or consistent dependent. And that all goes back to the word wall. Picture right from the board in our classroom. Once again, consistent means that they have one answer or infinite amount of answers. Inconsistent means that they have no answers. Consistent independent means one, so consistent independent is only one answer. Consistent dependent, one line lands on top of the other. It depends, right, on it. There's an infinite amount of points in common. So with that said, we should be able to just look at these graphs and see if they cross at one point, which would be consistent independent, or if they're parallel, which means inconsistent, or if it's the same exact line, which would be consistent dependent. So let's look at number one. It says x plus y equals 3. And if we look for x plus y equals 3, it's this equation, which means that it's this line right here. Okay, and the other one says x plus y equals negative 3. So x plus y equals negative 3 is down here. So if we take a look at this line and this line, let me color them, we can clearly see that they're parallel. So if we're looking for that point that they share, that's a point of intersection, which they never intersect. So this would be a no solution if we were looking for the answers, but we're not looking for the answers. We're just looking for the classification, which we know that parallel lines are inconsistent, right? Parallel lines are inconsistent. So let's just write that down for number one, inconsistent. Let's jump to number two. Number two, you have 2x minus y equals negative 3. So let's find that. 2x minus y equals negative 3 is right here. We're talking about this line right here. And then we also have 4x minus 2y equals negative 6. And here it is, 4x minus 2y equals negative 6. And as you can see, it's the same exact line. So what that really means, so if you were to graph it once, it's in red. If you were to graph it again in a different color, it'd be the same exact line. We know that the lines land on top of each other. So it's not about how many points they have. It's not about one point that they have in common. They have an infinite amount of points in common. In other words, the system right here on number two has an infinite amount of answers, infinitely many solutions. The classification of that, again, according to our word wall, when it's right on top of each other, the classification for that is a consistent dependent. So what we're going to do is just write down the answer number two, consistent dependent. Let's move on to number three over here. Number three, x plus 3y equals 3. Let's look for that. X plus 3y equals 3. That's this line right here, the black line. And then it says x plus y equals negative 3. And if we look for x plus y equals negative 3, we're talking about this blue line. So if we think about this blue line and this other black line, okay, once again, blue line, black line, where do they intersect? They intersect right there. That is the location, so that is our answer. This right here is our answer, if we were looking for the answer, but we're not. We're just want to classify it. So these two lines within this system, they do intersect, and they intersect at one point and one point only, which means that it's a consistent independent. Sorry about that. Consistent independent. Again, that's a consistent independent system. Let's move on to number four. Let's look for the equation x plus 3y equals 3. X plus 3y equals 3. Again, it's that black line. Let's look for 2x minus y equals negative 3. 2x minus y equals negative 3. It's this one, the red and green line. So you're looking at the black line and the red and green line. The black line, red and green line. So here's a black line, here's a red and green line. Where do they intersect? They intersect right here at that location. That is one specific answer. So once again, it is a consistent independent system. And why is that? Why is it independent? Because there's only one answer. Well, I'm sorry, right there, one answer. Consistent independent. Let's move on to the actual homework part down here where we actually have to do the work. Let's graph and find the answer. They want us to solve the system here. So they don't want us to classify anymore. They They want us to solve. So again, I'm using different colors. The top equation, I'm going in red. Subtract 3x. Subtract 3x. You're going to have a negative y equals negative 3x minus 2. Final step will be to multiply everything by negative 1, which is going to change all the signs. Positive y equals positive 3x plus 2. So this above equation crosses the y-axis. The b value is 2. Now from this point, you're going to go up 3 over 1, which means that you're going to be off the graph. Once again, you went up 1, 2, 3 over 1. There you are. So in order to draw this better, let's go backwards. Let's go over 1 this way, down 3. Over 1, down 3. So let's put a dot right there. Let's continue over 1, down 3. Let's draw our line through these dots. Put some arrows on it. Now let's look at the bottom equation. The bottom equation, I'm going in blue. I'm going to subtract 3x. It's going to be 0 right there. And subtract 3x. So let's rewrite this thing. It will be negative y equals negative 3x plus 0. Don't get confused with the 0. That just means that your b value is 0. Let's multiply everything by negative 1. So I'm going to change all the signs to make that y positive. So my final slope-intercept form equation is y equals positive 3x minus 0, but still plus 0 minus 0, it doesn't change anything. The b value is still 0. It crosses right through the origin. Now from that point, I need to go up 3 over 1, because that's my slope. So let's go up 3 over 1 and put a dot right there. And draw my line. That is the ugliest. Let me change that. I'm sorry. Here we go. One more time. That's better. Now, I could continue drawing this, but I didn't even have to draw this. Why? Because if I check both of my equations, once they're in slope-intercept form, I see that they're not the exact equation, but I do see that they have the same slope. And if they have the same slope, that means they're going in the same direction. They have the same steepness, which means that they're never going to cross. So if I'm looking for the answer, if I'm looking for the point that they share, if I'm looking for the point of intersection, and these lines are parallel, I know I'm never going to find it. So what does that mean the answer is? That there is no answer. So we say no. No solution. No solution is the correct answer. If they asked us to classify it, which they're not, this would be an inconsistent system. Let's move on to number 6. The top one's ready to graph. It crosses at negative 3. Right? It's already in slope-intercept form. It crosses at negative 3. You go up 2 over 1, up 2 over 1, up 2 over 1. There's my red line. Now, this bottom one, it's definitely not in slope-intercept form. I want to go on blue. And what I want to do is get y by itself. So it doesn't matter if you get y by itself on the left side or the right side, as long as you get y by itself. So since y is on the right side of the equal sign, I want to get rid of the 6 and then get rid of the 2. And then I'm going to switch the things around, and you'll see. So let's first get rid of that plus 6 by doing a minus 6 and a minus 6. So my new equation will be 4x minus 6. So let me write that down. 4x minus 6 equals 2y, because I have the equals and the 2y. Remember, the minus 6 is canceled. Now let's get y by itself. As you can see, y is not by itself. There's a multiplication of 2 right in front of it. So let's divide everything by 2. And we will have 2x, let me write it in blue, 2x minus 3 equals y. And let's write it the better way. Let's write the y on the left side. Y equals 2x minus 3. Now that's in slope-intercept form. Now I could graph it. It crosses at negative 3 as well. So I already found my point of intersection. However, it does go up 2 over 1, up 2 over 1, up 2 over 1. What does that mean? I'm talking it's the same exact line. So they are right on top of each other. If they asked us to classify it, the classification would be a consistent dependent system. However, they're not asking us to classify. They want us to find the answer, the x value and the y value. But the truth is there's an infinite amount of answers, so that's our answer right there. Infinitely many solutions. Number 7, the top equation. If you want to get y by itself, you're going to have to subtract x. Subtract x. You have 2y equals negative x plus 3. Remember, there's an invisible 1 in front of the x. So then you divide everything by 2. And you will get your equation in red. Y equals negative 1/2 x plus 3 divided by 2 is 1.5 or 1.5. Let's graph this thing. The b value is 1.5, so let's go to 1.5. That's halfway to 2. Between 1 and 2, it's halfway there. So that's your y-intercept value. Now from that point, I am going to look at my slope and go down 1 over 2. So when you go from this halfway point down 1 unit, it's to the next halfway point, and then over 2, and you put a dot right there. So, and then once again, if I were to go from that point, that halfway point, down 1 to this halfway point over 2, I'd end up right here. And there's my line. Draw my line. Whoops, kind of crooked, sorry. Now let's go to the bottom equation, the blue one. Let's subtract 3x. Subtract 3x. I will have negative y equals negative 3x minus 5. So I need that y to become positive. I'm going to multiply everything by negative 1, changing all the signs. I will have y equals positive 3x plus 5. So this one does cross at 5. 1, 2, 3, 4, 5. And let me put a dot right there. Now from this point, I'm going to go up 3 over 1. Up 1, 2, 3 over 1. It's off the graph. So let me go backwards. Over 1 this way, down 3. Over 1 this way, 1, 2, 3 right there. And of course I could continue over 1 this way, down 1, 2, 3 to get all the way to the edge of the graph. There's my blue line. Again, it's kind of crooked, I'm sorry. And this, let's extend the red line this way instead of this way. So if I went down 1 unit over 2, let's go over 2 this way and up 1. So you're at this halfway point. Go over 2 this way, up 1, you'll end up right here. So let's put a dot right there. And as you can see, if you connect the dots, it looks like this is the perfect point of intersection. And that perfect point of intersection from the origin is negative 1, comma, 1, 2. Negative 1 on the x, positive 2 on the y. So the answer is negative 1, comma, 2. The x value is negative 1, the y value is 2. If you wanted to double check that, you can. Simply plug in the negative 1 right here into the x, that's negative 1. Plug in the 2 right there, that's really a negative 1 plus 4 because 2 times 2 is 4. Negative 1 plus 4, it really does equal 3. So we have checked the top equation. Now let's check the bottom equation. Plug in negative 1 into the x. That's going to be 3 times negative 1, that's negative 3. And then minus, what's y? Y is really 2. So negative 3 minus 2, that really does give you a negative 5. So you've double checked it. You're absolutely positive that that's the correct answer to this system. We're going to go over this word problem on number 9. It says a used bookstore also started selling used CDs and videos. In the first week, the store sold 40 used CDs and videos at $4 per CD and $6 per video. And then it says the sale for both CDs and videos totaled $180. So that's a good chunk of information. We need to be able to come up with a system of equations for this information, okay? So the first bit of information comes right here from that in the first week, the store sold 40 CDs and videos, right? So we need to create an equation from that first bit of information. So what could we say in terms of an equation? What are the two things that we're dealing with? Are we dealing with bananas and oranges? No, if I was dealing with bananas and oranges, I might use the letter B and O. But right here, we're dealing with CDs and videos. So C and V, why not? So let's let C represent the number of CDs and V represent the number of videos. Sorry, my voice is going. And how many did they sell? 40 total, right? So I don't know how many CDs were sold, but I do know that if I add them with the numbers of videos sold, it ends up being a total of 40. Does that make sense? Okay, so you guys are going to have to create these equations on your own. Now, that was an equation based on the number of CDs and videos. Now, let's make another equation based on money, okay? Dinero, cash. So let's look at the rest of the information. It says that each CD was $4 per CD, and $6 per video. And then they tell you the total sale was 180. So let's create an equation based on money. So how much is a CD? $4. So I could put a $4 right here, but I need to multiply it by C. So 4C. Why is that? Because if I did sell one CD, well, 4 times 1, that would be $4, right? If I sold 2 CDs, that would be 4 times 2, that's $8 we made off of the CDs. If I sold 10 CDs, that would be 4 times 10, that's $40 we'd made off of the CDs. Does that make sense? So because it's $4 per CD, I put 4C. And how about the videos? How much were the videos? $6. So what am I going to put for the video one? 6V. So remember, we're talking about money here. So whatever I sold for the CDs, if it's 10, that'd be $40. But you're also going to add how many videos you sold. If you sold 10 videos, then that would be $60 because 6 times 10 is 60. But the bottom line is you put however much the CDs cost, however much the videos cost, and if you add those amounts together, you should get the total amount of sales. And what was the total amount of sales? 180. So 180. And this is a system of equations that we just created right now. Okay? This is your system. All we have to do now is solve the system by graphing it. So part A was to write a system representing this situation. That's what we did. And it all boiled down to the first equation being based on amount, like how many CDs do you have, how many videos do you have, how much is the total, it's 40, right? And the bottom equation was based on what? Money, right? And what do I mean by based on money? It's $4 per CD, it's $6 per video, and if you add the amounts together, it's the total amount of sales, $180. Okay? So that's how we created the system. Now they want us to graph the system of equations. Well, C is a variable, V is a variable. It's kind of like having X and Y. It's depends on what you call X and what you call Y. Let's look at the graph that they give us over here. So which one's the X-axis, which one's the Y-axis? Obviously, your CDs are your what? X's, right? And your videos are your what? The Y's, okay? So now we know that CDs are really the X's and the videos are the Y's. X's, Y's. So I guess we could rewrite our equation in terms of X's and Y's. So here it is, X plus Y equals 40. 4X plus 6Y equals 180. Okay? And if you want to graph both of those, you still need to get Y by itself. So I'm going to go to the top equation in red. You subtract X, you're going to have Y equals negative X plus 40. And the bottom equation, we're going to subtract 4X, subtract 4x, you're going to have 6y equals negative 4x plus 180. And of course, we still need to divide everything by 6. So we're going to have y equals negative 2/3. You can't really divide 4 by 6, but you could reduce 4/6, and it becomes negative 2/3. And the 180 divided by 6, you could actually do that. It'll be 30. Okay? So we have our red equation, which we're going to graph with the red line. We have our blue equation that we're going to graph with the blue line over here on this graph. So let's go with the blue one. It crosses at 30. So you're going to put a dot on the y-axis at 30. And then from that point, you look at your slope, and your slope is negative 2/3, which means that from this point, you're going to go down 2 over 3. Now, the problem with this is that you don't have 1 unit at a time. Right here, you actually have 5 units, right? But because you have 5 units on each interval on the y, and you have 5 units on each interval on the x's, you could actually treat it as 1. So you could say down 2 over 1, 2, 3, and you could put a dot there. Yeah, technically you did go down 10 and over 15, but it still works out. Negative 10 over 15 is the same thing as negative 2 over 3 if you reduce it. So right here, go down 2 over 3, you end up with that dot. Down 2 over 3, you end up with that dot. Down 2 over 3, you end up with that dot right there. And there's your blue line. Let's go for the red one. That one crosses at 40. Crosses way up here at 40. And you go down 1 over 1. Now down 1 over 1, I mean, if you just went to the actual down 1 unit over 1 unit, you'd get right there. And then down 1 over 1, down 1 over 1, that's kind of ridiculous. So instead of saying down 1 over 1, you could change it to down 5 over 5. Or you could look at it as down 1 over 1. And down 1 over 1. And down 1 over 1, and so on and so on. So let's do that. Let's start marking it. Down 1 over 1. So you're looking for the point of intersection. That point of intersection is clearly right here at that location. So the solution to this system would be how many videos sold and how many CDs sold. So the videos, how many? Anybody? 10. And how about CDs? CDs, 30. And that's the solution to that system that we created.